Well, welcome back, everybody. We're going to do a question of the week here with a special guest, Harvey. He came by the shop. Questions about cylinder knock or engine knock, what knock readings are, and if you're looking at your Accessport and all of the different windows that the Accessport gives you into knock events and whatnot, like find knock learning and so forth. What does all that stuff mean? And so, thinking about that question, I couldn't think of anybody better to bring in than Harvey, because being a tuner and having so much experience, you've had a lot of instances where you've run into knock or had to figure out what's going on with an engine, and worked with Accessports. So I wanted to bring you in to have a conversation about what knock is, and then all this information that we can get from the Accessports about knock. Well, what is the best way to interpret that?
Certainly, yeah. So I'll start off with saying knock is one of probably 4 or 5 different kind of quantifiable forms of abnormal combustion. So abnormal combustion is combustion that doesn't follow the path that we want it to follow. When we want normal combustion, we want it to be a nice hot kernel starting a flame, and the flame propagates at a certain speed, and it smoothly pushes the piston down.
Right, and it's started by the spark plug.
It is started by the
spark
ignition engine. That's what we're working with, because honestly, knock, it can damage engines, but it can also be in other engines, like compression ignition engines like diesels. Knock is the way that the engine works.
That's how it works.
So some engines work through knock, other engines we want to avoid it. And I think all of this is in the light of Subarus. This is sort of what I'm working with the most, and this is what your viewers really care about the most. And honestly, the quickest and best answer is to go upload or look up the Cobb knock monitoring guides. There is one specific to the EJ, and there's one specific to the FA engine. And they're very different because the engines actually not only register knock very differently, but they also behave very differently due to the differences in compression ratio, direct injection versus port injection.
Well, and the FAs, so the EJ engines, there's a single knock sensor, but on the FAs, there's actually 2 knock sensors.
Yeah, there's 2, and also, I mean, when we think about things like maintenance, one of the knock sensors, it's common for it to go bad, and there's been a recall on it.
Right.
So, we look at things and say, hey, some of this stuff is real knock, some of it's false knock, and what we want to talk about is go back to the drawing board and to the basics and talk about what normal combustion is, then what knock is.
Yeah.
And knock, the other thing is that there are different forms of knock, and the one that we really care about is the kind that we can have an effect on, because it's induced by ignition advance. And so there's a lot of factors that go into whether an engine's going to knock. One is octane, the other is design. But as far as a calibrator, which is my job, my part is to give it ignition advance that doesn't cause the knock, but also that optimizes the power at the crank. And the really hard part of my job is that those 2 things happen very close to each other. And there are even engines where knock happens before you reach the peak of power. And that's frustrating as a dyno tuner, because you guys probably have all read up on MBT, which is minimum best timing for peak torque. Yeah. If you can run the least amount of timing, you're probably not going to knock on a well-designed engine. But there are well-designed engines nowadays designed to run on all sorts of fuels, and those engines are going to knock before we get to peak power, unfortunately. Yeah. And that means that we become almost street tuners on the dyno, where we're like, oh, look, I just picked up another 10 or 15 horsepower with 1 degree of timing. But I gave it another, and I picked up another 10, but I'm getting knock readings. Whereas the EJ typically at low boost, 12, 15 pounds, normal street kind of tune boost levels, we're going to see even on 91 octane fuel, which these are all just factors into that come into play. It's almost like a puzzle where it's like, hey, I need a good engine design with low compression to run fairly low octane like 91, which I consider low octane these days just because of ethanol and race gas.
Well, and just because of its behavior compared to other fuels like a race gas, or especially ethanol, which is much more detonation resistant, and so you can it just behaves very differently than pump gas does.
Yeah, for sure. So those engines anyway, I'm running into knock never. I can tune the whole EJ at reasonable amounts of boost on 91 and not expect to see any knock if I'm being careful and moving slowly. It's still close to the ignition advance feature or number that I put in to knocking, but it's not that I don't have to sweep past it and then come back the way that a street tuner would without a dyno.
So let's maybe back up one touch, and what we should talk about timing and normal combustion, because you're talking about advancing timing, and
sure.
I think it's good to have for people to just have a picture of what is going on there, because then that helps inform what abnormal combustion is, which is, the knock that we're talking about.
Oh, sure, yeah.
So the piston at top dead center is basically when the piston is at its highest point in the cylinder.
Yeah,
so the piston goes up and down, and,
Mm-hmm.
and top dead center is at its highest point.
Mm-hmm.
And so with timing, relevant to the piston at top dead center. So are you trying to ignite the fuel at top dead center? Are you trying to ignite it before it's at top dead center? Or are you trying to ignite it after?
Oh, wow, that's such a difficult question, because I would have said before top dead center is common, but with direct injection and high compression these days, we are often igniting at peak torque after top dead center or at top dead center. So all three are possible. And you can even have knock at after top dead center firings because of the high compression of direct inject engines and trying to run, a lot of boost on one of those. But
let's maybe keep the example to a simpler EJ.
Okay.
And so in that case, where would you want to ignite the air and fuel mixture?
Usually before top dead center, quite a few degrees. So the other thing to talk about is how that relationship is, and why it's called a degree is because, and you say like when the piston's at the top, it's actually at the top for a couple degrees. It has a thing called dwell.
And we're talking about degrees of rotation of the crank.
Of the crankshaft, yeah. So the crankshaft, it's locomotion, which is the name of locomotives, and that's because they go like that.
Yeah.
So we're taking straight lines and turning them into circles. And top dead center, exact perfect top dead center, we talk about that as 0 degrees.
Right.
And then because it takes 4 cycles, like intake, compression, power, and then exhaust, that's a 720 degree double circle, you would call it.
For one complete cycle.
For one complete cycle. And the reality is that we probably only have about a 40 degree window of timing of that 720 for the ignition event to be occurring when it's at the right time.
40 degrees is basically your maximum window that you're working with.
Yeah, at wide open throttle.
For whatever conditions,
Yeah, I'd say throughout the range of an engine, it's probably closer to 70 or 80 degrees because, we're going to run up to 55 degrees advance at cruise and deep vacuum, which nobody looks at. If you told someone, hey, you're running around in your EJ and it's running 45 degrees when you're cruising, they'd be like, that's a lot of timing, because the conversation only really steers itself towards wide open throttle. The reasons that we have these extreme degrees of advance is that a flame won't propagate as fast in a deep vacuum because the molecules are so far apart.
So you said flame propagation.
Yes.
So that's where this degree of timing comes in. This is where the reason that you would start the flame front or ignite the flame front before the piston's at its top dead center point. That's where it comes in, because this flame front it takes time for the air and fuel to burn, and so that's where timing comes in. Is you're adjusting when you're igniting the air fuel mixture to basically get it to the point where you're kind of at the sweet spot when the piston is, or the crank is just rolling over top dead center to the point where the piston is ready to go down and actually extract some of the power from this air fuel mixture.
Yeah.
But you've got to optimize the timing of this combustion event.
Normal combustion happens at a flame front speed where it gradually burns your charge and it pushes the piston smoothly. Detonation happens when it all burns at once, or it all burns in a much shorter span of time.
Right.
And that's just not good for our type of engines. As a tuner, my job is to find a place where that happens less. And I'll say also...
Or not at all. Hopefully
yeah,
not at all.
But it's not also a light switch. This can happen mildly. It can happen very heavily. So there is a case to be made. And I think that I'm seeing it with the FA, even though we're not here to talk. We're more going to talk about the EJ. There is mild knock that you can register normally with the EJ or the FA engine. Mm-hmm. And the other thing is I get customers all the time that run off-the-shelf 91 and 93 maps, and people who are running on a 93 octane mix in that engine probably don't see much knock at all, but it's even normal to see knock on 91, and there's nothing I can do about it. There, like I said before, there are forms of knock that aren't anything to do with tuning. No matter what timing I give it, it will happen on 91 at light load at like 2,000 RPMs on an FA. So there are forms of knock that show up that it's like I've pulled 20 degrees out, richened it up, and it's still happening, and you're just like, oh, that's a design feature of the engine, plus the octane of the fuel. Right. It doesn't like it, but those types of knock events can be very much less damaging because they're not occurring when the cylinder is super full of molecules. So
since it's out of control or unexpected, you don't know exactly where the piston is going to be in its travel when this all happens, so then the forces are all going to be pushing against that piston. And that's where the issue comes in.
Typically, we see with normal combustion a nice pressure rise, and we can see it pushing the piston down. But with knock events, because it's sporadic, localized, different places, and it actually is, what you're hearing is waves traveling across the piston top and the bore, and they're actually pretty well defined as far as for a certain bore what that tone is. But these waves are you're hearing them, and that's why we call it knock.
Right.
But they're localized to where they're pushing. They're not pushing, say, the piston top all the time. They might be pushing on the cylinder head in just one little spot of the cylinder head. They might. So if you're measuring across with two pressure transducers across the bore at the top of the piston in the combustion chamber, you might see pressure localizations that don't have anything to do with moving the car forward. They have more to do with destroying the engine with these knock events.
You said something really important, which is that it's something that there is a frequency to it, and in a lot of cases you can't hear it.
Yeah.
Which brings you to the knock sensor.
Sure.
So how does the knock sensor pick up on one of these events, or what is it looking for?
It's a piezo, so it's a microphone, and it's looking for the frequency that system generates. So if I were to say take a fully built engine and hit it with a small hammer, it would generate a certain frequency based on the mass involved and its own properties of how this bell rings.
Yeah.
And what we're looking for is that sound. So you can actually simulate knock. There are systems that will induce knock on purpose, like standalones nowadays, and you can do it at moments that are not, again, that are low RPM,
very
low load.
RPM, light load.
Yeah, you can induce it, and then you can study that and then filter it out. So you're really using an audio filter to listen for that knock. But a lot of times, just because that makes that noise the same way that my fingertip made that same noise, it's going to make the same tone every time I hit it with anything. If I leave a loose bolt on the top of this, if I have loose components on it, if I have intercooler pipes smacking against it, all those things can induce false knock. Even driving over a gravel road or going over railroad tracks, and even starting
heat shields.
NVH, like the way that sounds propagate through the car. A lot of times we're isolating them, but then when we start doing things like stronger motor mounts, solid motor mounts, you're going to be able to go over a bump, and if a rock hits your frame really hard, it might transfer through this and make the right tone for the knock sensor to go off, just because I did stronger motor mounts or even shift linkage and bushings, things like that.
Yeah.
I think I see the most false knock on people who shift so hard, like people who really don't care about their synchros and think that they're race car drivers on the street. Those are the people.
The transmission and everything, it is literally bolted directly to the engine.
Yeah. And then you have things like twin plate clutches, all that stuff. You may not hear it because you're working so fast, but it's making a different tone, and it's transferring through the engines. I think a lot of people, they do two things, and that one is they don't understand that there's false knock to start with, and so they'll put up their Accessport and send me a photo of the Accessport, and it says, my car pulled out 7 degrees. Well, I'll say this. I typically, if I see that, and I had a log of it, a lot of times, that 7-degree pull is after it hit top red line and while the guy is shifting, and you can see that the boost has already dropped, and the knock happens then. Like, we're talking about milliseconds in the log where you zoom in and you're like, hey, it picked up knock, but I can see this guy already was shifting. He's bouncing off the rev limiter.
This is actually, you're shifting from one gear to the next.
You can actually, as an analyst of the data, you can actually sit there and say, hey, this is actually happening after. Or a lot of times, even if they're not shifting, if I'm going on a throttle angle input, not only is there some knock that happens due to take-up. I used to think it was all just take-up of mechanical components, like your gears are not meshed yet, or they're not under load, so they're like just kind of floating. And then I floor it, and that click transfers through the crankshaft and makes the noise, and then the knock sensor gets upset.
A knock sensor is not, it is looking for a symptom of a knock event. It is not able to read an actual knock event. It only can look for this frequency, this sound, this symptom.
Oh, yeah.
It can't actually read when this event actually happens.
Sure, yeah.
So there's a difference between a knock event and a knock reading from the sensor on the engine.
So there's always the question of like, hey, how do we, when I get a picture of an Accessport that just says it pulled out 5 degrees, I have to say, hey, I set up your Accessport to log for this. And usually when we send a customer out, actually always when we send a customer out, the most of the data refers to knock, because that's going to be the biggest tuning issue that I can do something about. And certainly we're watching other things like coolant temperature and whatnot. And that can actually influence knock. If you have an overheating engine, intake air temps, back pressure, fuel octane, all these things come into play.
They have an impact.
And I don't have a way to measure most of them. I can't see what the back pressure is or
not with the
or getting
standard
bad
ECU
gas
sensors and stuff.
So what we want to do is at that point we want to see what's going on in a data log. And another thing is a lot of the customers think to themselves, they've heard online things like, oh, you just watch feedback knock, you don't need the fine knock learning. Those are actually not only two different modes, but the fine knock learning will also report knock that might scare you way after it's happened and it's hung on to that reading and it's trying to just avoid future knocks.
You said whenever you finish a tune, you set up the Accessport to do a certain data logging, and a lot of it is focused on knock.
Sure.
So what, generally speaking, what kind of parameters do you set up the monitoring for?
I'll say the timing maps are based on two axes, and one is RPM, the other is calculated load. So that's how much air is in the cylinder in terms of grams as far as mass. So if we can look at those two things, we can pinpoint where on the map the problem is occurring and then do something about it with regard to ignition advance.
What about the knock parameters that the Accessport lets you choose from? Which ones do you typically like to monitor?
Yeah, so I like anything I can get on that one, because we've got feedback, knock correction, and fine knock learning are my two biggest ones that I like to watch. And I'll say I also put up DAM as a third one, the dynamic advanced multiplier, or some people call it ignition advanced multiplier. Those three things are probably the three most important ones, but you have another four which really help isolate it, which is the knock sum for each individual cylinder. Once Subaru went to drive-by-wire systems in 2006, all the cars started to monitor not just knock sums, but knock sums from each cylinder. You've got 720 degrees, but only 40 of those degrees, which are spaced evenly in that 720-degree circle, have a chance of knocking on any one of those cylinders. So if you can say, like, oh, yeah, it happened at this angle of the 720, I know it was this cylinder, because that's the only one with any sort of spark going off or about to go off.
The ECU knows which spark plug is firing and which cylinder that is. Yeah. And if the knock sensor triggers as it's firing the spark plug, it says, well, that's cylinder 2.
Yeah. And really the EJ system is a lot different from the FA system. It looks at knock very differently. It just counts a sum. It just is a click. And maybe in the background it's a lot more the same, but from what I can see in my software, and it's very different to analyze knock in the two systems. But we also see in the EJ that the cylinder number 4 has the knock sensor located right above it and bolted to it. So cylinder 4, I see tons of knock sums, and the engine will never pick that up as a knock itself. But if people watch me tune, they might go home, and I've had this happen where they start sending me messages like, oh, the knock sum on cylinder 4 is awful. Did you turn off the feedback and fine knock learn for cylinder 4? And it's like, no, the guys at Subaru knew that it was bolted up there too. And in certain conditions, they're ignoring it because they should. Because it's
back to, is it a knock reading or is it an actual knock event?
Yeah, so even Subaru's got some pretty good filtering, even though the reading looks like it's saying it's a knock sum. Yeah. Subaru's even like, yeah, it said it, but we still know that it isn't.
So so the two, other than dynamic advanced multiplier, which I think that's people are pretty familiar with that, and we'll touch on it, but feedback knock and fine knock learning. So what is each one of those doing? Like, what
I think it's very complicated to get into that subject, because even as a tuner I've been doing this since 2005, and I would still say that I challenge anyone to know exactly what the math is behind how it switches between those two modes. But those are basically two separate modes of knock detection, and it can kick from one to the other. So you kind of got to watch both, and they're kind of doing the same thing. It's not like one is listening harder and the other's kind of letting things go.
Fine knock learning, I mean, that to me implies that it is like pulling timing, or it's making a change to the map, whereas feedback knock, that would be closer. That would be closer to here's a knock event. Like the knock sensor triggered, that would be more in the feedback knock realm of collection. Versus fine knock learning is like, oh, hey, this is the degree to which we're making a change. Yeah. Because of the knock.
I think it is that way. I mean, you're definitely never going to have a preemptive psychic knock sensing system that does it before it ever happens. Feedback and find, knock, learn. Find, knock, learn is the word learn. It's there. So it hangs on to it. And if it doesn't see it for a while, it lets it go. So often I'll see someone say, oh my gosh, it's always pulling out 2 degrees at this RPM. And that's horrible. And when I look at the data, the knock sums may show that it only happened once. And then that find, knock, learn, for whatever reason, just doesn't want to let go of that pull of timing. And so it's pulling out, say, 2 or 3 degrees in this one zone. And I'm looking at it and I'm going, it is learned, but it's not letting go of it, which I think feedback knock is always going to be a case where it saw it and then it just does it for a certain couple of strokes or whatever. And then it starts deteriorating, letting it go.
Right. So my first question there is, how common is it, like you just tuned a car, you sent the customer, on their drive home, and they drive the car a little bit. How common is it to get some kind of a number, some kind of a value in either feedback knock or find, knock, learning? Is it something that happens fairly often? Is it something that happens rarely? It
depends on the car and the build. I would say a stock car in really good condition, they generally don't see much of anything. Maybe 1 or 2 degrees get pulled out a couple times a day. On a really good, safe tune. But on, say, a higher compression engine that someone put together in their garage and they've got a lot of loose parts and maybe they have solid motor mounts, we might see it all the time. And then we were talking about what the 2 piston materials, 2618 is the one that I don't like in street cars because it's probably a stronger piston because it has less silicon in it and it's less brittle.
This is the one that expands.
But it expands way too much for a street car. So a lot of guys will come in and say, oh, I lost my rod. But is this rod knock? This new engine I bought from this guy that built it for me, it sounds like it has rod knock. And I'm like, no, he just did pretty big piston wall clearances because those pistons, they probably do get quiet going down the drag strip. They get quiet at the road course maybe. But they will never get quiet on the street because they're
30 minutes after driving, it's probably pretty quiet. But you first start up when everything is cold.
Not even then. I think some of those you have to push wide open throttle. Maybe 30 minutes of driving at wide open throttle, they will finally get quiet. But they're setting off the knock sensor falsely because this person spec'd out, oh, I want the strongest pistons possible because I never want my engine to die again. Well, they just built themselves something that's setting off the knock sensor falsely all the time.
Lastly, let's talk about dynamic advanced multiplier, the DAM.
Sure.
So what is that? What is the Accessport telling you with that number?
Well, I think less what it's telling me is it's not as important what it's telling me as the tuner as how it all works because while feedback and find, knock, learning will raise and lower the DAM is actually an additive to the whole picture and an overall indicator of your octane value.
So what way I've had it explained to me is that it's the engine's willingness to add timing.
Yes.
Because when you tune a car and you set the timing, that is not 100% razor fixed. The ECU has ability to make some adjustments, like it can pull timing out.
And honestly, it's a couple of tables. So the same way that you look at a timing table and it's a grid with timing, there's a second grid, and that's the dynamic advance table. And it's a table of timing similar to the timing table, and we get it to tell it what the authority is. From the factory, it's up to 12 degrees in some of these ECUs, 13 degrees. Of extra advance
or extra advance
and pulling, well, not really either direction, but extra advance. So these tables are layered. So I have a timing table that does this, and then I have the DAM table that does this and gives me even more timing. So if I'm at say the value 1 for a modern one or 16 on an older ECU, the 16-bit ECU. So on a 16-bit ECU, the number goes from 0 to 16, and that's the same as going from 0 to 1 on a modern ECU. So if I have, say, a dynamic advanced table where all the values are 10 and my DAM is at 5 or 0.5, say that the values in there are 10 extra degrees, but my DAM value is 0.5, it will only give me 5 of those extra degrees. When I get down to a DAM value low enough, there's actually a separate table it switches to, but that table, it basically gives the portion of that table extra timing. So the DAM tells you, hey, my overall fuel quality is bad because that whole table's been shaved away and it's giving me none of it. Or it says, wow, it's giving it the full value of 10 degrees. I think most tuners these days are settling on a value of about 5 degrees extra over the base table of timing.
take that to the next step or clarify what that would mean, is that means, okay, well, you're tuning the car, you have the car in a controlled environment, and you're setting the timing. You could push that timing right to the very ragged edge, but you know that, okay, well, then the dynamic advance, it wouldn't be able to go any further.
Yeah.
So you're actually giving a window. You're actually pulling the set timing value back so that you're letting the ECU add that last bit of timing in because you know how many degrees it can or will add.
Yeah.
So that you're actually, well, I guess you as an experienced tuner are basically letting the ECU take the last 5% of the tune so that if all of the running conditions are good and it's happy with all the other data that it's seeing, then it will take it up to the value that you know is there, that you could have put in, but you didn't because you want to give the ECU its normal ability that it comes from with the factory to adapt based on what it's seeing for fuel quality, what have you. So would you say from that maybe the dynamic advanced reading coupled with the knock reading, that you want to look at all of these things together, and if you're seeing some fine knock learning or something like that, but the dynamic advanced multiplier is still 1, well, okay, the ECU overall is still happy and willing to add timing as it does, so probably the knock readings are not so significant that it's really causing a lot of the ECU to pull timing significantly or whatever. Whereas if you have like a lot of knock readings or a lot of fine knock learning, but the dynamic advanced multiplier is then say at 0.5 or something like that, then the knock reading with the lower dam, that combination then might say, okay, something has changed. Maybe I got a bad tank of gas, something like that. And then that's where, okay, I need to try and do some more data logging. I need to get more data, more of a picture of what's going on that might be causing both of these parameters. Something that's changing the dynamic advanced multiplier and
you have a clogged injector. You could have all sorts of things. A cooling system problem where the car's running around overheating, where they're not noticing that part because they're focused on the knock.
Right.
And I'll say also as the dam drops, the knock learning starts to go into positive values as it's trying to reach itself back up as the dam's trying to rise, because all of these things have a decay, or they have an additive that lets it come back to normal, or to try to see if the octane's okay again. And you can set how long that takes or things like that. And so while that dam is down, it's the only time you'll see positive knock correction values. So if you don't have a minus near it and you're like, hey, my car's giving me a degree of timing in feedback knock, but it doesn't have a minus, that's usually because the dam has dropped and it's trying to seek its way back up. Is when we see that behavior. Okay.
Yeah. So there's, it definitely, they're all worth paying attention to.
Yeah.
But you've got to try and think about context and like.
Yeah, and I'll say it's almost like, wow, they filter out each other, and when you finally get to the dam, it's almost something that if you don't like anxiety, the dam is the easiest one to watch because it's definitely going to move. If you're getting a lot of knock, it's going to drop. But it's not so hyperactive the way that feedback and fine knock learn are that you're going to freak out about data. And if you don't know how to look at the data and you just look at the max and min values that are kind of small on the Accessport, that's going to freak you out because there is normal.
So this is where it's saying like here's the maximum fine knock learning, here's the minimum in like a drive cycle. Like here's all the range.
And another good piece of advice for fine knock and feedback, and I think that this applies. This is probably the golden nugget for you guys and what you're trying to look for. That is that all those values are pretty dynamic and they move sometimes. But when we don't want them moving is to be consistent at wide open throttle. So the way to watch for knock is you reset your ECU, you put it in third or fourth gear, just some gear that you're not going to get arrested in, and you floor it right before you know it's going to be capable of hitting boost. So like on a stock turbo, say 2,800 RPMs, you want to just kind of smoothly go to the floor, not like smack it to the floor, especially if you could get some mechanical noise out of that. You smoothly push it wide open throttle, and then you just wait till it gets to about 6,000 RPMs. You could take it to redline if you want, but you don't want to see it knock once it's in boost. Once it's finally hit boost and it's holding that and the RPMs are going up, you want that to be pretty clear of knock. It can do it sometimes, and I'll say maybe 1 to 2.5 degrees. That's normal once in a while in different spots on some cars. I like to see it never, but I mean, I wouldn't freak out if it happened on one pull and then the next pull it didn't happen.
Right. So there's all these variable conditions, and like you were saying, the ECU has a little bit of filtering for these knock readings and knock sensors that it is doing in the background, and that this just programmed into how the ECU works.
Sure.
And that maybe in and of itself should be the indicator to you, like, well, if Subaru knows that there's enough variability here that the ECU is filtering these readings, and it doesn't make big changes until it's looking at a big chunk of data.
Sure, yeah.
Well, that's where you don't want to make any decisions or jump to any conclusions until you're looking at a big piece of data.
Yeah.
And really, like, to me, what that comes back to is looking at dynamic advance. Like, don't start looking at find knock learning or knock. Look at the dynamic advance.
Yeah.
Because that's giving you basically like the ultimate output of what the ECU's opinion is of how everything is running.
Certainly, yeah.
So, like, if the dynamic advance is good, like, there's no real need to go in and start looking at knock events because the ECU is determined, like, no, everything is within normal parameters. I'm willing to add timing in as much as I could. I'm not going to limit myself because of all these readings. If dynamic advance starts to go down, then maybe start looking at the knock readings specifically. Because then the dam coming down, that's an indication that something else is happening, maybe. And maybe the find knock learning or knock.
Yeah, I'll say feedback, find knock learn. I would say it's safe to look at those, but not while you're driving.
Sure.
But you know, to analyze the logs, you people don't want to look at the screen and see and freak out about what you see on the screen after a pull. You want to be able to record it. And
even if you're data logging, sure, add them to the data log. But if you're going to have something on the display for the Accessport, and you're concerned about the engine function, engine happiness,
DAM is probably better.
DAM is what you want to look at on the Accessport.
Yeah, and again, we're relating this to the EJ. When you get into the FA, it's perfectly normal to have the DAM move much more often. The DAM on the FA is supposed to be something that moves up and down.
That's an important point. That's good.
Yeah.
Well, and that makes sense to a certain extent because it's a direct injected engine. It is running at higher compression. Because it's direct injection with the high compression, the ECU has the ability to play around with these like areas, these fringe conditions where knock could and would be more likely to occur.
Yeah. We talk about it having a much more sensitive knock sensor and having a much different way of looking at the filtration of knock readings. So I think what you're getting to is also that I haven't mentioned yet is that knock isn't just a switch where it starts happening or it isn't happening. There's mild knock. It's a progressive thing that happens worse and worse, and maybe we can't hear some of it that's not damaging, and it's normal to have a slight amount of this, like when you see the pressure wave to have a little bit of this even on a good tune. That FA engine is starting to see that the noise levels on the cylinders are much more well defined, and it's in a format that goes like from 0 to 10,000 on each cylinder as far as noise levels, and then it has a filtering system that says this is knock or this isn't knock. But it's not a switch; it's a progressive thing. I watch as I give these cars timing, that knock sensor get noisier and noisier, but not trip as knock. So then we have an even deeper layer with the FA.
I like that picture of thinking of the feedback knock, find knock learning, and then the DAM and how they relate to each other. I think if anything from this conversation is going to be the most valuable to you watching this, it's kind of that better understanding of how those things relate to each other. And then just the understanding that, like, the ECU, and especially with the FAs, it sounds like, is doing some filtering of those knock readings. So if you're looking straight at those readings, you know, that's the ECU has some kind of logic built into it to filter that. And so, like, if you're just looking at the raw reading, you know, that's not even what the ECU would necessarily work from.
I mean, again, if you guys just put up your knock sum, cylinder 4 is just going to go haywire. I see sometimes hundreds of knock readings or knock sums on cylinder 4 with zero knock events on feedback, find knock learn, and this is on perfectly normal cars that work correctly. So that can be really disconcerting to sort of data analysts who don't understand how it works. And so we get a lot of those guys, you know, engineers that love their car so much, and they think that a perfectly tuned Subaru will never have even a knock sum. And then I show them, I'll literally pull up a comparison to a stock file, and I'll say, look, all of this knock data is stock as far as how it filters. And it's not even caring about these sums. It says it has it doesn't give a crap about it. And it's and you do, but you are wrong to do that.
Well, what that filtering that the ECU tells you is that Subaru, who set up the car and set up the factory mapping, they know that there's a lot going on there. Yeah, you don't want to just look at that one number and focus on it entirely. You've got to pull back, know that the ECU has some logic going on as well. And then, again, I think ultimately what I come down to this, or from this conversation, is the dynamic advanced multiplier is going to be a much better place to look rather than specific any knock readings, because that's kind of giving you a much more holistic version of what the ECU is doing and what the engine is doing versus like specific knock events.
Sure.
Hopefully that helps. Hopefully that gives you guys more of an insight into what the ECU is doing and how to read these values. And thanks very much for your support as always. Check out Harvey at the Boost Creep. He is the tuner that we've been working with forever, and he's a wealth of knowledge and a really good tuner to boot. So thanks so much for Harvey for coming down and spending time. Thanks for watching, and until next time, stay tuned with Flatirons Tuning.
Thank you so much.